Okay, and let me copy something over real quick. Hold on. Okay, free hint for everyone in the room. The test you take on Thursday, I believe, has 3 questions, at least 3, that are going to test whether you understand the definition of concave up or concave down. Okay? That doesn't mean they're going to test you visually to see if you can see when something is concave down or concave up. They're going to test to see if you understand the definition. So I'm going to tell you the definition. I told you before, I'm going to tell you again. If you don't understand the definition, now's the time to keep talking about it until you do. Otherwise, the question will fool you. It's exactly what Kylie said earlier, and there's another point. It's not, it's like you've got to think, okay, what should I be thinking when I'm seeing a problem that's dealing with concave down or concave up? So as you read this problem, they give a clue here, which I'll be honest, the first time I solved the problem, I didn't really know why they had given me that clue. I couldn't see any reason for it. So I just move on. This clue I know. I've seen it before many times, so it didn't trick me at all. See, f double prime has a negative y coordinate, therefore f is concave down. So here's the definition of f being concave down. When you look at the graph of f, if you are looking at the dots, you're looking at the y-coordinates of f. Okay? And you can see whether the dots go up or down. That's this part up here. Is f increasing or decreasing? Okay? That's the y-coordinates going up or down. But when you look at f, you also need to look at the tangent slopes. So, right here at this point, there is a tangent slope. Right here, there's a different tangent, and then a different one, and a different one. Each point has a different tangent slope. Okay? All of these slopes are slanted upwards. They slant in an upward direction, that's how we read that. However, the values of each of those slopes are not going up, they're going down. Because this one has a quite positive slant, but as we follow the curve, we see slants that are less and less positive. So if you were to make up some numbers here, you might say the slopes are, just counting down. I don't know that they are, but it's the right idea. So when you have a concave down curve, the slopes, as you read the curve, will decrease. As you go across the curve, point by point, you'll see values of tangent slopes that go down. The D in Danica's chart is what reminds me of that. Because remember, these numbers become the y-coordinates of f prime. And it says right here, the y-coordinates of f prime will go down. So that's the definition of concave down. And we want to talk more about that. That's what you have to understand. Once it's understood, you flashcard it, and you memorize it. So. Cool. Extension. If I know that I can follow the curve and see that every tangent, from tangent slope to tangent slope, will have a decreasing value, the same is true for secant slopes. Okay? So if you start here and you skip past a whole bunch of tangents and you go to there, that secant slope, it's hard to draw, brother, the pattern still has to be decreasing. So this is a tangent slope whose value is 9. This is a tangent slope whose value is 4. Well, the secant in between, I don't know the value, but it's got to be between 9 and 4. So this secant slope value here in the middle, it's got to be between 9 and 4. SS is not an official abbreviation. I just use it all the time as a note-taking aid. So the secant slope of the red must be between 4 and 9. Otherwise, the curve would not be concave down. Question? Okay, forgot who asked the question, but what's happening here is you have all these tables, and they're expecting you to do what Kylie said again, another point. They're saying, hey, you should be thinking about what does concave down mean. And you're thinking, oh, that means the tangent slopes must have a decreasing pattern. But I can't find a tangent slope from a table, so let's do secant slopes. Because if the curve is concave down, the tangents will have a decreasing pattern, so will the secants. Sydney, please.
Wait, why did you choose 9 and 4 as like it's gonna be in between those two numbers? Like, why could it be like 3 and 9, or like, I guess I'm a little confused on that.
Oh, so the idea is, if f is concave down, then as I follow f, I will find that the slope values have to go down in value.
Yeah.
Good with that?
Mm-hmm.
If the tangent slopes have to go down in value, then so do secant slopes.
Yeah.
So if I drew another secant like here, this secant has a value that is greater than this secant slope. But if you alternate, it also is true. So this tangent is 9. Now I'm going to jump past all these other tangents to go to this one. So the secant slope has some value. This tangent has a value of 4. Well, from the 9 to this slope to the 4 has to be a decreasing pattern. So this secant slope might be 6 or something. Or maybe it's 7. Maybe it's 8. Maybe it's 5. I don't really know.
Yeah.
I just know it's less than 9 and greater than 4.
Okay, so that could be true for any of those numbers on a concave down.
Mm-hmm.
Okay.
Yeah, and like here, this secant slope, it's got to be less than 4.
Mm-hmm.
Got to be greater than 2.
Okay, yeah.
That's what I meant.
So on this problem up there, it says f double prime x is less than. Say that was a greater than sign, would that make it concave out?
Right, so everything just reverses. So now the slopes must have an increasing pattern. So 2 for Justin and 2 for Susan. You else want to talk more? Please.
I don't know if you're gonna get to this, but so the tangent slopes have to decrease. So when you're looking at the f of x or whatever, that's decreasing, so you can cross out like c and d. But then how do you know
Let's
which?
pause there for a second. You're
Okay.
okay. 2 points for a good question. So what we said was the f that we pick must be an f that is a concave down shape. That means the values of the slopes have to go down. These are the y-coordinates of f.
Okay.
They don't have to go down.
Just the one in between, like.
The slopes.
Okay.
So when I do this in-between thing, I'm finding secant slope.
Mhm.
I'm saying the change in x is 1, and then the change in y is 2.5. So that secant slope is that.
Yeah.
Now so I'm following the curve, I'm going from one point to another. Now I'm going to go to another, from x equal 3 to x equal 4. That secant slope becomes 1.5 over 1. So far, this looks just fine. As I went from one x coordinate to the next, the secant slopes did decrease as I followed the curve.
Yeah.
So that's a possible correct answer. Unfortunately, as always, there's more than one.
But I just don't get why it's that one. I don't know. Because I kind of just guessed at one point. Because I was just like,
Guessing
oh, that
is
makes sense,
guessing
but-
is what you want to do on the test when you've exhausted all other methods.
Yeah.
But when you're studying, you never want to end with a guess.
Yeah.
Yeah.
So I just didn't know why it was like the right answer is A, but like why it is A and not B or something.
You're okay. Good question. Okay. Anyone else want to talk about the idea that if the curve is concave down, I must see three things. I have to see all the tangents values decreasing, I have to see all the secant values decreasing, I have to see alternating slopes that decrease. Okay, it's the last clue that's how you solve this. Alternating slopes must decrease. But you got to understand what that meant. Alternating slopes must decrease. This right here means the tangent slope of f at x equal 3 will have a value of 2. So they're saying if this is f, let's draw this one. Then the secant from the first 2 points, the secant slope, this is also Sydney's question, there's another point. The secant slope will have a value of 1.5. The next secant slope, actually the tangent slope right here at 3, this tangent slope has to have a value of 2. That's what the other clue is saying. Come on. There we go. This tangent slope has to have a value of 2. But according to this chart, I messed up, I'm backwards, sorry, this is 2. The next secant here also has a value of 2. Okay, just use your common sense. Look at the picture. It says, dang, I cannot do anything right. Raise your hand if you have been very confused by what I'm writing on the board. 2 points. Take 3, take 4, take 5. You have it right now. Look. This chart says the secant from this point to this point will have a secant slope of 2. The tangent right at x equal 3 will have a tangent slope of 2. How the heck do you draw that? Like, how do I draw, like, these aren't the same slope. This red one is not the same as the green. The curve can't be concave down unless you follow the definition. As I alternate from secant to tangent to secant, I must have a decreasing pattern. That is not possible with this table and this clue. You need me to talk, you want to talk more about that.
So it's like that secant slope is 2 and then the tangent slope is 2. You can't.
Impossible. Like on your paper, try it. Like try to draw a curve that's concave down, has this shape, make the first secant have a slope. Doesn't matter what the slope is. That is identical to this tangent slope. Like try to make those 2 lines have the same steepness. I think steepness is a word. You can't do it. The curve would not be concave down if that's happening. This slope can't be 2 when this slope is 2. So that curve cannot be concave down. We want to talk more about that.
So that's why we have to be 2.5, not 2. For it. So like that's why we could have A or B so far.
So B is a problem as well.
Because it's the one after it.
It's the one after it. So now you're trying to draw this. You're trying to say, okay, I want the first secant to be 2.5. That's great. So I can draw that. So this secant slope here is 2.5. I need the tangent at x equal 3. That's a good one. I need that tangent to equal 2. That's fine because I went secant, tangent, decreasing pattern. But how do I draw another secant whose value is also 2? You can't if the curve is concave down. You must have a decreasing pattern. So one more time, I'll warn you, last time. If you do not understand what is meant by the definition of concave down, you're going to miss 3 questions on the test. It's that simple. Like, you have to do what Kylie talked about. You have to see the word concave down, and you have to see the definition. It just has to be in your head. Question? I want to talk more about this. So that's why A is the correct answer, because I can draw A and it fits the definition of concave down. I have a curve where the secant slope is 2.5. I have a tangent whose slope is 2. These are good. And then I have a secant slope whose value is 1.5. That fits the definition for a concave down curve. Those are nice, would you not say? Like, my preference, I'm the type of personality that I prefer to just be by myself and do things I'm not. Teaching's the wrong profession for me, because I don't really like to be in front of people. The trouble is, I'm addicted to helping you. Okay? I'm not kidding. Like, I don't like to be in front of the class, but I love to see, like, you can sense it. Like when somebody really makes sense of an idea and that you can feel that they suddenly made a change. I love that. Like, they really made sense of. That's all the reason I like teaching. But I have had this weird vision of an assembly. Don't ever do this. But like, I think on United sometime, they should. I wouldn't be the right person to do it because I'm too self-conscious. But somebody could act it out. Like all my calculus students would laugh. I think like the assembly is really simple. There's a video. You just like show a big screen like this. It's really quiet. There's no sound or anything. I just walk onto the stage, draw a curve, straight line, straight line, straight line, walk back off. Oh yeah, sorry, you have to go like this. Okay. Is that the right gesture?
Yeah.
I'm old, I don't know the right gesture.
I just don't understand the two.
Hold on a second. Please.
So I get like why it's A now and like why, I don't know. But I just want to know, is there like a correlation to like between the difference of the secant slopes? Does that have anything to do with like why that A is the right answer? Because like for
good
B and
question.
C, it's like the difference of the secant slopes is 0.5, but then on A it's 1. Does it matter?
Good question, sir. Hey. I suppose if I really thought about it, I might be able to invent some sort of problem where the change in the secant slopes would have some significance. Never have ever seen that.
Okay.
Yeah, so I don't know of any
Okay.
reason. Good comments here before I stop the video, please.
I'm still a little confused. How do you know that f prime of 3 equals 2? At that point, I mean, the tangent slope of f will be 2. Like, how did you know?
So that one is really, this will sound kind of silly, but it's really true. Like, the only reason I know that your name is Sydney is because you told me. The only reason you know that this means that the tangent slope on the graph of f, when x is equal to 3, will have a value of 2, is because I told you. Like, it's just memorized fact. Yeah, it's just, that's the symbol that they invented that means that. Now, Sydney, it means something else as well that we use less often. It means that on the graph of f prime at x equals 3, the y-coordinate will be 2. Because every y-coordinate of f prime is a slope of f. Does that answer your question?
Yeah, so it's like
Just that one's just memorized, yeah. There's no real understanding there, it's just memorized fact. But the fact does go along with the whole idea that every y-coordinate of f prime is a tangent slope value on f. There you go. Please.
So that's kind of how I figured out
This answer is finding the difference between secant slopes. Is that, so like?
Yeah, that's not gonna help. Yeah, good question, Kenny. Yeah, finding the difference between the secant slopes, I don't see any past problem they've ever given where that would be a semester. If I am remembering incorrectly, I will apologize in the future, but I don't remember. Anybody else? Okay,